All right, number 11, we have some inequalities that we want to solve. And I would first start out by moving everything to the same side of the inequality. So we have x squared greater than or equal to x plus 12. So I would subtract x from both sides. And that would give me x squared minus x, and then is greater than or equal to, goes to 0, just 12. And then I would subtract 12 from both sides. And that would give us x squared minus x minus 12 is greater than or equal to 0. And now that this is set to 0, we're going to factor this side to figure out what our critical points are. So 1 times 12 is 12. Factors of 12 are 1 and 12, 2 and 6, 3 and 4. You want to subtract to get a 1. These will subtract and give you 1. And then we're going to split up our x squared. Put our numbers 3 and 4 in there, and you can use math intuition to figure out, okay, what do I have to do to get a negative 1? Well, that has to be negative, this has to be positive. Or you can just follow the signs. The first sign is your bigger number out of the ones you added. The second sign, if it's positive, they're the same. If it's negative, they are different. And since you know the first one, they have to be different, and you get this. All right, so now that we have this, we're going to do a number line. We're going to put our critical values on the number line. When I say critical values, the numbers that make this equation equal to 0 are kind of like our cutoff points. So you will get a 0 at negative 3 and positive 4. Okay, opposite sign when you set these equal to 0. So remember what we're doing is, x plus 3 equals 0. You would subtract 3 to solve for x, and you get x equals negative 3. And you would do the same thing for the other one, so you're getting the opposite sign. So these are my critical values. We have broken our number line into 3 parts: negative infinity to negative 3, negative 3 to 4, and then 4 to infinity. We're going to pick a number between negative infinity and 3, something relatively small and easy to work with, probably like a negative 5. I could also use negative 4. Anything will work. Pick a number between negative 3 and positive 4 that's easy to work with. 0 or 1 would be ideal. 0 will probably be the best. And then between 4 and positive infinity, we'll just go with the positive 5. Now, doesn't matter what number you pick in here, but the smaller the better. All the numbers are going to do the same thing. So that's why we pick what we call critical points, because it tells us where it possibly changes and does something different. Sometimes it does the same, but whatever number you pick is going to be the same for all numbers in this interval, same for all numbers in this interval, and it's going to be the same for all numbers in this interval. What we're going to do is plug these numbers in for x and see if we get something greater than 0. So if I plug in a negative 5, I have a negative 5 plus 3, and then I have a negative 5 minus 4. Is that greater than or equal to 0? So this gives me a negative 2, and this gives me negative 9. When I multiply negative 2 and negative 9, negative times a negative gives me a positive 18, and 18 is greater than or equal to 0, so that checks out. So this interval is positive, which means greater than 0. That's one of the ones I'm looking for. So part of my answer is going to be this interval, negative infinity up to negative 3. And we do use a bracket on the 3 because of the equality on the interval sign. All right, now we're going to pick 0, do the same thing. I'm going to do 0 plus 3. I'm plugging it into the factor form. It's easier to do it that way. You can plug it in there. We'll do the same. And then I'm going to do 0 minus 4. see, is that greater than or equal to 0? So I get a 3 here, and then I get a negative 4 here. When I do 3 times negative 4, that gives me a negative 12, and negative 12 is not greater than 0. It's less than 0, so I don't want that section. It is negative, and I'm looking for the positive sections. And then I have one more. I'm going to plug in a 5 for this last section. So I'm going to do 5 plus 3, and then 5 minus 4. See if that's greater than or equal to 0, otherwise positive. And that will give me a positive 8. This will give me a positive 1. 8 times 1 is a positive 8, and positive numbers are always greater than 0. So that one checks out as well. So this interval was positive. So this is also part of my solution. Bracket 4 to infinity. And you put a union to say that you have 2 parts. And so we're going to do that here. We're going to do keypad. I need the open, close. That's negative infinity, comma, negative 3. And then I need the union symbol. And I need 4 to infinity. All right, so number 12, we're going to be doing something similar, same deal, except this time it's already factored for me, so I can find my critical values a lot easier. It is x plus 4, and then x minus 4. We want that to be greater than or equal to 0. So again, I'm looking for positive. All right, so my intervals, my critical values would be 0, negative 4, and positive 4. So I'm going to do my number line. So that's negative infinity. This is positive infinity. And then my numbers are 0, negative 4, and positive 4. Any number over here, I'm going to pick negative 5. Between negative 4 and 0, I'll just pick a negative 1, small. Between 0 and 4, I'll pick a positive 1. And between 4 and infinity, I'll just pick positive 5. Again, I'm just picking the smallest whole number that I can use in that interval to make it easy. Now we're going to plug those in and see what we get. So I will do negative 5, and then negative 5 plus 4, and then negative 5 minus 4. Now, let me just show you a calculator here. I got to open it back up. And it just helps with speeding up calculations and everything, but you can do this again by hand just like I did on the first one. But you don't have to go and work it out every time. You can just kind of write it down. So you still need to find the critical values, put them on the number line. You still need to pick some values, and then once you do that, we can just label this number line. So I'm going to go to y equal. I'm going to clear out what I have, and then I'm going to type in this expression, x parentheses x plus 4, and then parentheses x minus 4. And then I want to look at the table. I'm going to do second graph and look at the table. So we are looking for positive, okay? So if it's positive, I'm going to write it, and if it's negative, I'm going to write it. And the ones I want are the positive, greater than 0. So right now we're at negative 4. I'm going to arrow up and see what we get on negative 5. So when we get negative 5, we get a negative 45. So this will be a negative interval, okay, because it showed me a negative 45, which negative is not greater than 0. Then we had the number negative 1. So if you just scroll down, see negative 1, the y value is showing a positive 15. So that interval will be positive. This is one of the ones that I want. Then I'm going to look at positive 1. Positive 1 gives us a negative 15. That is less than 0. So this is not an interval that we want. And then I'm going to just go down to positive 5. Positive 5 is showing a positive 45. And so that is greater than 0. So this is one of the ones I want. We want the positive intervals. It can be equal to 0. So I will use brackets on the whole number parts. So between negative 4 and 0 is positive. And you can also see that on the table. So if I go up to negative 4, right here is 0 or positive because greater than or equal to 0. And then if I look at negative 3, negative 2, negative 1, all of those are positive. And then when you get to 0, you're back at 0. So every number between here is either 0 or greater. And that's why you don't have to test every number. You just pick one. And they all will follow the same pattern. And then my last interval is 4 to infinity. So union bracket positive 4 to infinity, close parentheses. So that's how you can use your calculator and it save you a little bit of math and possibly some mistakes if you mess up on multiplying and miss a sign or something like that. Bracket negative 4 comma 0, and then I need union and I need the close open. I'm going to do a positive 4 to infinity.